Hey everybody, welcome back. In this video, we're going to be talking about the questions from Module 6 on the Final Exam Study Guide. In the previous two videos, I talked about Module 4 and Module 5 respectively. So in this video, we're going to be covering questions 21 through 32, and in the next video, we'll cover Module 7. So Module 6 was talking about the student's t-distribution, which in your packet, you have the page that has the formula chart or the table of values for the student's t-distribution. And so this is what we use primarily in Module 6. So in this part of the review, I'm going to be talking about how to use that formula chart. So numbers 21 through 24 are questions where you have to determine what's called a critical t-value. And I've included a little snippet down here which shows the top of that formula chart, because the top is really an important spot to make sure that you find the right value. So looking at 21 through 24, these are all questions where you're being asked, like I said, to calculate a critical t-value. And so these are questions where you don't have to do any calculations, but you do need to know how to use the formula chart, the student's t-distribution, which will of course be given to you on the final exam. You just have to be able to use it properly. So let's do a couple of examples together. In number 21, it tells us that we're looking for a 90% confidence interval when the sample size is 18. In order to use the table, you need a row and a column to match up in order to find the critical t-value. The row is what we call the degrees of freedom, and it's always one less than the sample size. And so when you do this type of a problem, you don't have to necessarily write it all out. I'm just writing it out so that you can see why we do this. It's the degrees of freedom formula. So we're going to be looking at row 17 for this one, for example. And then the column is determined by what other information is given. So this one gives us a 90% confidence interval. And if you look at that formula chart, it's got 3 sections across the top. And sometimes you'll be asked for about a hypothesis test, but sometimes you'll also be asked for about a confidence interval. That's this third section right here that has the letter C. The C stands for confidence interval. And the 90% corresponds with 0.9. That's the column you're going to want to follow down until you get to row 17. So the column here, I'm going to write C. And since this was a 90% confidence interval, that's the same thing as 0.90. And it looks like the formula chart has 3 decimals in it, so I'm going to put a third 0 back there. And now let's look at the entire formula chart here. So we're looking at row 17, and the column that has the 0.9 in it, or 90%. Right, so you need to find this C row up here and go to the 90% level, and then take it down, go to the 17th row, and there it is, 1.740. That's what we call T critical. And when it's a confidence interval, it's going to be a plus minus of that value, 1.740, because a confidence interval has a left side and a right side, lower and upper. That's what this plus minus refers to. Now let's try another example. I'm going to do number 23. 22 has the same confidence interval, but a different row, so you can practice that one. I'll do 23 since it's a different confidence interval. Doing the same thing, finding a t critical value. This time the row is row 11, because our sample size is 12, we subtract 1. The column is going to be, since it asks for a confidence interval, we're going to look at the section across the top that has the C in it, 95%. So the 95% tells us 0.950 is what we're looking at. So if we match up 11, row 11, with the column that has the 950 in it, there it is, 2.201. 2.201. The T critical here, plus or minus 2.201. Those would be your answers here. So this type of a question on the final exam will give you pretty much this type of phrasing, and then the answer choices will be different T critical values. You'll need to find the correct one. So practice 22 and 24 on your own, and you can compare with the key. Let's keep going ahead. When you look at 25 through 28, these are all examples that have to do with vocabulary questions. And so I'm going to kind of explain these similarly to what is given in the answer key towards the back for 25 through 28. So as you can see towards the back, uh, 25 and 28 give you some descriptions here, 27 and 28 as well. So I'm going to kind of walk through that in a phrased more simply, but you can also read those definitions as well. So for number 25, it says, as the degrees of freedom increases, what happens to the student's T distribution? So it's asking, when you look at this chart, as the degrees of freedom increases, what happens to these numbers right here? So if you look in every single column, as you start from the top and go down, what happens to the T value, T critical value? Like it looks like it's getting smaller. Looks like it's getting smaller. But also on top of that, you have this row down here. Now this row right here is when your degrees of freedom is very large, infinity. These numbers right here are essentially the same values as your Z critical values. So I'm just going to make a note of that. These values down here are basically your Z critical values. So as your degrees of freedom increases, our T critical values are approaching and getting closer to our Z critical values. So simply summarized, we would say as DF increases, T critical I'm going to say becomes closer to Z critical. And then number 26 asks something similar. As degrees of freedom increases, what happens to the critical T values? So what we can say as df increases, what is actually happening to the numbers in the chart as I go down the rows? Any of these columns that I go down, right? I start a really big number. As I go further down the columns throughout the rows, you'll notice that our T critical values are getting smaller and smaller as we go down. No matter what column you choose, you're getting those smaller and smaller values as you go down. So as your degrees of freedom increases, meaning as you go down the list, your T critical value decreases in value. Right, so as degrees of freedom increases, T critical decreases. Number 27 and 28 are asking about what assumptions are made when you're using a T value instead of a Z value. So for 27, we use a T value when the population standard deviation is unknown. So we don't know the population standard deviation. And then there's also some other details included in the definition towards the back of the back of the packet. So be sure to look at that as well. But this is one of the main assumptions is that your population standard deviation is unknown. Actually, I'm going to flip over to that page just to kind of look through it. Yeah, so right here it says we do not know the population standard deviation. It lists a few other things. Our data comes from a normal distribution. We have no outliers. Um, and the confidence levels and the hypothesis testing for the mean, as well as the correlation coefficient, these are all applicable in this type of a distribution. But the main detail that helps you remember this type of question is we do not know the population standard deviation. And then while we are still here on number 28, the question is asking about what's the main indicator, whether to use Z or T. When we know or don't know the population standard deviation, that's what indicates to us to use Z or T. So simply put, on number 28, when do we use Z is when population standard deviation is known. When do we use T? When population standard deviation is unknown. Okay, let's look at number 29 now. Number 29 says, if we run a hypothesis test, what would be the critical t-value for the following types of tests and sample sizes? So these questions also go back to using this formula chart right here. And so I'm going to work out a couple of examples for this section here. For part A, it says we're using a left-tailed test where n equals 30 and alpha is 0.05. And up here, you'll notice that you've got two other sections that we didn't use. On the previous problems, we used the confidence interval section here. In this problem, we're using either one tail or two tail. If it says left or right, those are each one tail. And then if it's a two tail, you'd use the two tail area. So looking at part A, it says left-tailed. Let's write out, just to be really clear, the row and the column. The row still applies the same way. Degrees of freedom is 1 less than n. So our degrees of freedom is going to be 1 less than 30 or 29. And then our column depends on the other information given. So the alpha value and the left-tailed tell us that we're going to use the column that has the 0, 5, 0 in it, and is also, since it's left tail, it's a one tail. So looking at our formula chart, we're going to go to row 29. There's row 29. And then we're going to need to find the one tail area. And this problem was looking for 0, 5, 0, this right here, this middle column. So we can kind of draw around what we already wrote, going down this middle column to 1.699. And since this is a left tail test, we're going to want to put a negative in front of our answer. Anytime you have a left-tailed hypothesis test, your t-critical is on the left side of the number line, which is on the negative side. So the left tail means put a negative in front of that 1.699. So there's how you do a left-tailed test. Do the same thing for part B. Let's talk about part C, which is a right-tailed. All the steps are the same. The only thing that we don't do is we don't use the negative on a right tail. We just keep it as a positive on a right tail. So for part C, we've got row and a column. So our row here is going to be 11. Our column is going to be alpha equals, so that's 0.100, and this is one tail. So let's go over to formula chart. Okay, so looking at the one tail areas, we've got this one is 0.01, this one is 0.1. We want the one that looks exactly the same, 100, this one right here for one tail area. So make sure you're very careful about where the decimal is placed in each of these values. We want this third column. Going down to row 11, which is already highlighted, 1.363 is where we would end up for that 1.363. So T critical equals 1.363. There you go. So that's a right till. We don't need a negative, it's on the right side. Same thing for part D, so you can practice that. And then for two tail, I'll show you part E. All the same steps, we just don't need to, what we would do for a right two tail is put a plus and a minus in our answer. Left tail is negative, right tail is positive, two tail is both. The row and the column, we do all the same stuff though. So we're looking at row 21. And then we're looking at the column that has an alpha value of 0.05, and then you could put his extra zero back there because that's what the formula chart has. And this is a two-tailed situation. And remember that this is a two-tailed, so plus minus needs to go first, and then let's go find our value. Row 21, and then look at the two-tailed area for 050. So here's row 21. And our two-tailed area, make sure you look at the second row up here, 050, there it is. If I follow that down, to row 21, 2.080, 2.080. And there's your T critical value. So I've done one of each of those examples. See if you can fill in B, C, B, D, and F. Worked out the same way that I did each of those three there. Number 30, 31, and 32, these are examples where you're asked about one aspect of the hypothesis test. It gives you some information. And on number 30, it asks, if we want to test this claim, what would our alternate hypothesis be? So this has to do with step one that we talked about earlier. And we're testing out an average here, so mu. And it says, we believe the cinnamon rolls are larger than. So you're going to want to look for words that indicate a direction, since the alternate test is either going to have a less than, a greater than, or a not equals. It's got to be one of these three. And when it's larger than, it's going to be the greater than symbol. So in this case, our alternate H1 is going to be mu is greater than 7, because our number here is 7. Right, you can practice 31 and 32 similarly, but I think I want to go over it together. That way it kind of makes sense for the alternate hypothesis. Each of these asks for an alternate hypothesis. So 31 says a company selling mixed nuts claims that their packages contain no more than 50% peanuts. So our number involved is 50%. And it looks like we're saying we believe there are greater than 50% peanuts. Greater than indicates above. We're going to use the greater than symbol, H1. And in this case, it's going to be, since it's a percentage, P is greater than 0.5 because it's a 50%. So 50% is 0.5. This is not an average. This is a proportion or a percentage. P is greater than 0.50. And the last one right here, talking about $500 saved on average. So that's a mean. So this is definitely going to involve mu, and I just need to determine what's the symbol? Mu something 500. And it looks like this one tells us that we did a sample and we found the savings to be 350. It looks like 350 is less than 500. So in that case, we want to use a less than symbol. We're not saving $500, we're saving less than $500. So that's why we use a less than right there. Just comparing those two numbers. So that brings us to the end of Module 6. Okay, if you had questions about any of these problems, please be sure to email me, reach out to me, or see me during office hours and I can clarify anything you need to. In the next video, we're going to finish up with Module 7.